So welcome back, Level 2 NCEA Chemist, continuing on with the Organic Chemistry External. Today looking at the functional group known as the amines. So the class name, of course, is the amines. The general formula is RNH2, where R can be alkyl, or potentially H for one, ammonia. The functional group name is the amino group. General formula there is CnH2n plus 1 NH2, where N is the number of carbons. And you can see the functional group is basically a nitrogen with two hydrogens attached. And the suffix we use for amines, amine. So in terms of naming them, and we'll go into a little bit more detail in the next slide, essentially you're using the suffix amine, and the prefix is going to be for basically the same as for alkanes and alkenes, and for the other functional groups we've used, so meth, eth, prop, for example. So, for example, a one carbon amine is methanamine, because one carbon is meth. And at the bottom there, you also see you can also have geometrical isomers. So if it's of the amine group is on the second carbon, then of propane, a 3-carbon chain, then it'll be propan-2-amine. So getting to the numbering, it's very similar to what we've been doing with the other functional groups. Basically, you select the longest chain, and then you number the carbon with the smallest number or lowest number, which has that amino functional group. Okay, and then the corresponding substituents are then named from that point. In terms of Level 2 NCEA Chemistry, you only have to be able to name the primary amines. So that's amines where the amino group is attached to a carbon, which is only attached to either a hydrogen or another carbon, one more carbon. Oh, sorry, better name this. Okay, so for the example we've got there, so the longest chain is 1, 2, 3, 4, 5 amine, 5 carbons, so it'll be pentan. Okay, it's an amine, so pentanamine, but you'll note that the amino group is on the third carbon, so it'll be pentan-3-amine. So there we go. In terms of the physical properties, melting points and boiling points of amines, similar with the other functional groups, that as the number of carbons increases, so does the melting and boiling points, as you can see from the table. And the explanation is also very similar to the other functional groups. Okay, as the number of carbons increases in the chain, the number of intermolecular bonds between the molecules increases, which means more energy is required to break those intermolecular bonds, hence the melting and boiling points go up. You'll also note, just like with the alcohols, there is hydrogen bonding, a special type of intermolecular bonding between the amino groups, because the amino group is a polar bond, meaning there is a positive pole to the bond, which is the hydrogen, and a negative pole to the bond, which is nitrogen. And obviously positives and negatives attract in terms of the intermolecular bonding. And due to that, amines have a higher melting and boiling point compared, for example, to the alkanes, because alkanes do not have these hydrogen bonds, which are relatively stronger than the other intermolecular bonding available. And in terms of solubility of amines, as the number of carbons increases on the amine, then again it will become more insoluble, and it's the same reason we saw for the alcohols. The amino group is hydrophilic, okay, so it allows hydrogen bonding with the solvent water, whereas the long carbon chains are insoluble. Okay, there is no intermolecular bonding between the water molecules and the solvent and the long carbon chain. So as the carbon chain gets longer, the more insoluble the appropriate amine is. In terms of the reactions, we have a substitution reaction. So basically, if you have an haloalkane where X can be chlorine, bromine, iodine, it reacts with excess ammonia in an alcoholic solution with a bit of heat in a sealed tube to make the corresponding primary amine. And finally, in terms of physical properties, amines are bases. So it means that when you dissolve amine in water, it will take a hydrogen from the water to form the corresponding ammonium ion and give a hydroxide ion. Okay, so that means that in solution, amines are basic due to the formation of the ammonium ion and the formation of the hydroxide ions. They're also weak amines, which essentially means that a majority of the solution is the actual amine and a little bit of a hydroxide forms. Okay. And that's pretty much all you need to know around amines.